So outside temperature over a day can be modeled by a sinusoidal function. So that could be sine or cosine. Suppose you know the high temperature of the day is 81, the low temperature is 69 degrees, occurs at 4 a.m. So suppose you know the high temperature for the day is 81 degrees and the low temperature of 69 occurs at 4 a.m. Assuming T is the number of hours since midnight, find an equation for the temperature D in terms of T. All right, let's give it a try. So I'm gonna graph this out. 69 and 81. Yeah, so I'm going to draw my y-axis in, and then I'm going to make a little break in it, break, and then I'm going to draw the x-axis. So I don't really want to draw all the way down to 0, if that makes sense. And then we need to show a full day, so 24 hours. So I'm going to scale by 2, I think. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there's my time since midnight. And then 4 a.m., so 4 hours later, so this would be 4 a.m. right there. That's where the low of 69 is going to happen. So I'm going to put 69 right here, which is why I broke my axis there. And then the high is going to be 81. So let's just put 81 up here. And the low happens at 4 a.m. And if we assume this pattern continues for a few days, then the next low will be at the next 4 a.m. So that would be 24, 26, 28 hours after that first midnight. So we'll get that low again occurring over here. The peak should occur in between there, right? So 12 hours later after 4 plus 12 is what, 16. So that's going to put me over here. So the peak should be here. So that is one complete wave. So let's draw that in, go up. Oh, that's not very good. Actually, I want to draw the midline before I draw my wave. Let's get rid of that. Let's find the midline. So the average temperature is just 69 plus 81 over 2. So what's that give me? 9 and 81 is 90. 90 and 60 is 150. Divide by 2 gives me a midline of y equals 75. So right in the middle here is our midline, 75. And that also helps me find my amplitude. Might as well do that now. Amplitude would be the difference, right, divided by 2. So oops, let's do it the other way. 81 minus 69 over 2, which is what, 12 over 2 or 6. Yeah, that seems reasonable. So distance from here to here is 6. So let's draw in that midline. Let's use, say, green. So there's my midline roughly. Oops. Again. All right. And then we're going to hit the midline right in between the min and the max. So 6 hours after. So that means here at 10, we'll hit that midline. And how am I getting that? Again, we've got 24 hours for the whole cycle. Half of that to get from the max to the min, and half again to get to the midline from the max or the min. So that's 24 hours total, 12 hours to the middle, 6 hours would be a quarter, 6 hours after 4 is 10. So I'm going to hit right there. And then another 6 after 16, so that'd be 22 right there. Okay, so that's my wave there. So we curve up to that. And then down here, and then back there, and then it's just going to keep going that way. And let's see, 6 hours back this way will hit the midline, so that would be 2 hours before midnight, about here will hit. So this wave comes up through there like that. All right, so which curve do I want to do to graph this? I think I'm going to go for a sine, and I'm going to use this right here as my translation for the sines. Remember, the sine starts at its midline and goes up to the max. So then I have this shift right here. So that's going to be my horizontal shift. It's called a phase shift. So I'm getting a phase shift of 10. I have my amplitude of 6, my midline of 75, right? My midline is my vertical shift. The phase shift is the horizontal shift. The amplitude right there is the vertical stretch. And then for the horizontal stretch, B, or horizontal stretch or compression, this one's a stretch. We got to use the period to figure that out. So we have a period of 24, and the period always comes from 2 pi over B, our multiple. So then multiply B up, 24 down, 2 pi over 24, gives me pi over 12 as the multiplier to get the horizontal stretch. So the function, again, I'm looking for is a sine. So we have A times the sine of B parentheses X minus H plus K. So K, right, that's my midline, my vertical shift. A, that's my amplitude here. And my H, that's the phase shift here, my horizontal shift. So I think this function, we'll graph it to double check, make sure it has the right points, is 6 times the sine of pi over 12 parentheses X minus 10, close parentheses, plus 75 to get it up to the right spot. So that should model this temperature. Let's graph it and check. That was a lot of work. Is it right? So again, the points we're looking for, we'll try to isolate, say this point right here for 69. 16 goes with the max of 81, and then we have our first midline temperature of 75, 10 hours after midnight. See if we have those 3 points. All right, again, I'm going to use f of x. Maybe I'll need that notation in a minute to test it. I think it's 6 times the sine of pi over 12, another parentheses for the shift, x minus 10. And then we need to shift that all the way up to 75. So we're going to have to redraw this. So the monkey wrench is a good way to do that rather than zooming out, I think. So as far as x goes, maybe I want to see like, how about -10? And let's go past 24 hours, maybe up 30 hours later. And then the y, let's see, we had a min of 69. So maybe I'll look from like 60. Max was 81, maybe I'll go up to 90. All right, so there's my wave. So again, how did I come up with those numbers? I was envisioning this picture I drew right here. So I wanted to see a little to the left of midnight here and then past one period. And then I needed to get 69 to 81 in there. So I picked 60 to 90. And the monkey wrench here lets you change that rather than fiddling with zoom and moving the screen around. All right, how did we do? Well, let's graph the midline too. We think the midline should be y equals 75. So there's that one. So the minimum should occur, whoa, I didn't mean to zoom. Stop it. Oh, sorry, my touchpad's going crazy on me here. All right, let's not do that again. All right, so I want to know what that min there is. There's my 469. Okay, so I definitely get that point. And then we should have a max here, 1681. That was on my graph. And then the 1075. Yeah, I got those 3 points I was targeting based on reading the problem. So important aspects of this question. Draw this out, right? You could put it in a table. That's okay too. But drawing it out is super helpful, and you have to really think about, how does the temperature change over 24 hours? So from midnight, it's going to get cooler, and then eventually it's going to start warming up again. Sun rises, and then we're going to max out at some particular time. Here they're maxing out at 16 o'clock. And then 24 hours after that min, right, we should get another min. And then we had to decide whether to use a sine or a cosine. And again, I pick sine here. If I picked cosine, then I would be looking for a shift related to the maximum there, which I could have done. So my claim, if I use that maximum, that would have a shift of 16. So I should be able to get the same graph. Ooh, and it says use t, not x. Forget that. But one good thing about the homework problems is they tell you if you enter the wrong variable. So I click here, it says, hey, use t. If I try to type in x, it should give me a warning. Syntax error, check your variables. I thank you, computer. So sweet of you. All right, back here. So I claim that I could get the same wave by using a cosine and with a shift of 16. So that would be 6 times the cosine, same period. So we use the multiplier of pi over 12 to get the 24-hour period. Parentheses, but this time I would go t minus 16 because the cosine starts with its peak on the axis. We want to move that way over here. And then plus 75. Let's graph that, see if it is the same function, just to test out my theory. Oh, and the function notation, I forgot I was going to mention that. I can, if I need to find specific numbers that aren't, the graph isn't giving me, and Desmos and GeoGebra are great, they give me very nice numbers on the graph that I'm looking for. But like, suppose they told me the temperature at 5 o'clock was blah, 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 then I would just type f of 5, and it'll just spit that out, and I could change f to 5 to 4, and it gives me that number. What's happening at 16 hours later? There's my 81. All right, so let's make a new function, g of x. This time we'll use the cosine. So 6 cosine pi over 12, parentheses, x minus 16. Close the parentheses yet again, and then add the 75. And notice that black sits right on top of the blue. So I'll turn that off, turn it off. There we go. So there's my blue. There's my cosine. Blue was the sine, black is the cosine. Same graph, different function based on the different phase shift. Cool.